Why does sweating cool you down?
That is an excellent question, LeBron. And to answer it, let's zoom in on a little droplet of sweat. And sweat is mostly water, so when we zoom in, and we've really zoomed in even more than I've drawn over here, when we really zoom in, we'll start seeing mainly these water molecules. And the water molecules, just to be a little bit more accurate, I've drawn the oxygen in blue, and then the hydrogens that are bonded with that oxygen, I've done in white. We all know that water is sometimes referred to as H2, that's for the two hydrogens, H2O. So each of these are a molecule of H2O or a molecule of water. What I've drawn down here, and this is an oversimplification of the molecules of your skin, but just for simplification, these are the molecules of your skin, really the parts of the skin cell. These aren't even the skin cells themselves. These are the molecules that make up the skin cells. And right over here, these are molecules of sweat, or it's really just molecules of water. So the question of why does sweat cool you down could really be restated as, why does having water on the surface of your skin actually cool you down? And to answer that, or to think about that question, we have to think about what it means to have temperature, or what temperature even really means. Temperature, what we perceive as temperature, is really just the motion of the molecules of something. So a higher temperature means that they're moving around more. So high temperature, they're moving around more. Low temperature, they're moving around less. And they can move around in different ways. They can have what you could call translational motion, which is they're actually moving around. They could be vibrating. They could be rotating in some way. And in general, on average, the more of this motional energy, often referred to as kinetic energy, that these molecules have on average, the higher the perceived temperature would be. Now, how does having this water here cool down the skin? And well, first of all, why is the skin warming up? Because the muscles are doing all of this work. They're releasing heat. That heat is being transferred to the skin. But then how does having this water here help? Well, this skin has a certain temperature, a certain kinetic energy or motional energy. But when we say that, it doesn't mean that all of these molecules have the exact same motion. The temperature is the average motion. Some of these are bumping around at a faster speed, or vibrating at a faster speed, or rotating at a faster speed. Some are doing it at a slower speed. But as these bump around, they're going to bump into these water molecules and start to get them moving around. They will probably be moving around a little bit to begin with, but then the warmer this is, the more energy here, they'll bump into these molecules. So let's say that guy bumps into that, then he'll bump over there. And so that energy, this bumping energy, or this kinetic energy, some of it will be transferred, or you could even say some of that temperature, some of that heat will be transferred to these water molecules. But the important thing to remember is, not all, this is a really kind of crazy thing. They're all bumping into each other and rotating in all sorts of crazy ways. They will have an average kinetic energy, which we perceive as temperature, but they all have, this one might be going really, really, really fast, while in that direction, while this one might be going really, 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 really slow. This one might be going really, really, really fast in that direction. This one might be going really slow in this direction. So the thing to think about is, given that you have all of this variation in the energy of each of these particles, which of these are most likely to escape, to actually evaporate? And to think about evaporation, you just have to think about that most water molecules, or the water molecules that are in that droplet, they do have an attraction to each other. We call those hydrogen bonds. So they do have an attraction to each other, and that's why a droplet kind of sticks together. But if one of these molecules is moving fast enough, and if it's moving in the right direction, it has a higher probability of being able to actually escape that droplet. And this process of these molecules escaping, that's what we refer to as evaporation. Evaporation. If a molecule has enough energy, it'll escape the bonds with the other water molecules, and just evaporate into the air. But we still haven't fully answered our question. So let's say that this one is one that has evaporated. It has fully escaped. Why would that actually cool down this entire system? Why would it cool down the droplet and essentially give it more capability to accept more energy from the skin? Well, we just said the ones that have the highest energy are the ones that are most likely to escape, the ones that have the highest kinetic energy. So if you have a bunch of stuff, some are fast, some are slow, vibrating a lot, vibrating less, but the ones that have a high kinetic energy are the ones most likely to escape, what happens when they escape? Well, then the average kinetic energy will go down, or you could say the temperature, which is really just the average amount of motion or kinetic energy that's in this droplet. If the really fast ones, the ones with a lot of energy, are leaving, then the ones that are left over are on average going to have a lower kinetic energy or a lower temperature. And so that is what is cooling you down at a molecular level. Let's first think